Okay, this video shows you how we can import this little file. Okay, so this is imported using DXF release 12. It has to be release 12 because other versions of the DXF interface use NURBS, which we can't read in. NURBS are just a particular mathematical formula for describing curves. So we need arcs and lines, and you can get that using release 12. This is the file that we've imported. So we can do a couple of things. If we need to, we can reset our datum, which as you can see is the bottom left corner now, where that would come from the original DXF file. So if we want to reset our datum, we use the NC button here, and then the set NC datum tag. So we need to go into no snap so that we can just position the datum point where we want it to be. Okay, so that would be just roughly in the center of that shape. If we wanted to, we could draw a couple of lines across there, and then where they intersect in the center, that would be the datum. Okay, so to create all those shapes as contours, we can use the automatic method. So if we go to select, and then we click and drag a box around the area, so those are all highlighted, then we come up to the top menu here and go machining, automatic NC parts, and we want to create contours. Contours are a series of linked line and arc segments that the cutter will follow. Patterns are for drilling holes. So we're not doing any drilling on this one for the moment, or at all, so we'll just use contours. And then if you read through this, it's got two methods of doing it, so you want to say yes to that. Okay, so the depth is whatever depth you want it to be. Now you notice that the line thickness here is 0.25 of a millimeter, so when it's creating the contours, it's just using that as a guide so that you can see that it's done something. But also in this case we can use it to visualize what the tool will look like. Okay, so it tells us that those contours have been created. So the thing that may be apparent is that on this little letter I here, there's almost no gap between the upstroke and the dot, and that's what might be causing the problem with not seeing that. So what I'll do is, if we just undo the making of those contours, okay. So I think what we might need to do here is, although not strictly correct to the original drawing, is that we might need to move that slightly. So to do that, we'd use move an area, and then if we use the mouse wheel to zoom in and out, and click down on the mouse wheel to drag the graphic. So we're in move mode, so we can just click and drag around that area, click at a reference point within the area, and then just move it ever so slightly up. So not exactly 100%, but then it will mean that you have some sort of gap between those two bits of geometry there, and that may be causing the problem with the not seeing the letter, the dot over the eye. Okay, so we go back into here, where NC, we do select, those contours, go into automatic NC parts, yes, give this nominal depth. Okay, so I think that looks a wee bit better there. Okay, so save this file away, and we'll take that into machining. Okay, so because this is the new job, we get the machine set up, so we need to check on our tool change position. So we probably need to have a small value in the z-axis here. It doesn't matter too much what we put in there, but none of these values here in the z-axis can be 0, even though you're going to be using the machine to set and reset your cutting depths and so on, but they mustn't be 0. Okay, so that's the graphics in the CAM system. So to produce the tool path, we define the tool. So we're going to be using an end mill and give it a diameter. The length is however long the tool is, and the cut depth, normally this would be the depth of cut that you want it to have, but that can also be used if you want to change the cut depth at any time so that it takes multiple cuts. I'll show you how that works in a second. Okay, so that's defined the tool. Now we need to select that tool for use. So this is where we set the spindle speed and the feed rates. Normally we'd be using feed per minute, so we have two feed rates, the XY feed rate and the Z feed rate, but again the Z will be controlled by you. If you've got auto coolant on the machine and you want to use it, switch it on here. So that's selected that tool for use. Now we can do go round command. So what we can do here is it will name just the first contour. We give it a depth. The offset will be set to none because we want the tool to follow the center line. The approach and run off, we can switch those off because we don't need them. What those are for is to give a nice lead on and lead off to a contour, but we don't need those, so we'll just switch those both off for now. And under the Z-axis tab here, if we did want to take multiple cuts down to depth, then we would use the cut depth here. So if we had 0.25 deep and you said you want a cut depth of 0.1, what you'd get is 3 cuts there. But instead of having 2 cuts of 0.1 and 1 of 0.05, you'd get 3 individual cuts of just under 0.07. So if you want to use that here, you can do. Otherwise you can just run the program 3 times and set your Z slightly differently. Okay, so that's created the go round command for that single contour, but of course it automatically made a number of contours for us. So if we double click on that go round command, and then under the options tab we select the box machine all contours with the same group number, so that will machine all the contours there. Okay, so if we zoom in on that, we can, this is the tool Centerline, which just goes over the top of the graphic. You can see the rapid lines there in red. If we switch on the tool envelope, then we can see the size of the cutter. And if you want to animate the tool, then you'll see the tool cutting round. So this is how it will cut. And because we chose automatic contour creation, we don't have any real control over the way it's going to cut. It's just going to choose its own method. But as long as they're all cut, it doesn't really matter. Okay. So that's how that gets created, and then to post-process that for the MX2, we choose that from the list of post-processors. The MX2, there we go. So that's the G-code file that gets sent down to the machine, but that will all get converted into events when it hits the machine. If you want to rotate that around by 90 degrees, you can use the repeat button here. So what this does is that the repeat sequence needs a start and an end. So this is the start of the repeat sequence, and we want to rotate, by 90 degrees, about 0, 0. Okay, so the start repeat needs to be before the go round command, so you just simply click and drag that up to there, and then for each start repeat you need a finish, so you click repeat again, and this becomes the end sequence. So all we've done is we've selected a tool, started the repeat sequence, which in this case is a rotate, do the go round command, and then end it. So now if we run that, that will just take that toolpath and twist it round by 90 degrees. But if you do that, don't forget then that you've got to re-post process to get the G-codes to take account of that. So that's the G-code file, which is a straightforward text file. When you post process, it will call it a particular name, so you might need to change this when you put it onto your floppy disk, and it'll probably need to be a program number, and the file name will need to be filename.cam, so that the MX2 can read it in. Okay, so that's how you do that.